we're Team A of Dr. Esfahani's Fall 2025 ChBE 321 Unit Ops Lab. My name's Haley.
I'm Alyssa.
I'm Olivia.
I'm Logan.
Come with us as we show you what experiments you're going to be running and some tips and tricks we wish we knew when we started this class.
Let's head to the lab.
But wait, safety first. Make sure you put your hair up, your glasses on, put on a lab coat, and gloves.
Hey y'all, come along with me as we look at experiment 1, where we'll be identifying unknown cooking oils and motor oils. Alright, so in order to calculate density in this experiment, you're going to need mass. So here is a mass balance. Some tips and tricks in using this is make sure that you report an accurate amount of decimal places to ensure accurate measurements, as well as each trial there should be a little bit of variance between the measurements to ensure you have a standard deviation between measurements. Alright, so now that we covered how to take mass measurements to calculate density, we're also going to be looking at how to get viscosity measurements. So we're going to be doing this using Zahn cups. So here I grabbed Zahn cup labeled 1 and 5, and the difference will be for the different diameter hole on the bottom of the cup. So for a more viscous oil, as we heat at the temperatures, we're going to be taking some measurements, and for more viscous, we're going to be using the bigger hole, and for less viscous, we're going to be using the smaller diameter hole. So when using these Zahn cups, you want to, I'll give you a brief tutorial in a minute, but you just want to ensure that your time frame when using a stopwatch is between 20 to 60 seconds. So here's a brief tutorial. You would place the Zahn cup in the beaker, wait till it fills, lift it up, immediately start the stopwatch, and as soon as the water stops, stop it again. As you can see here, 3 seconds. Not good. Zahn cup number 5. So you'd keep playing with the numbers until you got to that 20 to 60 optimal range. So I know in the tutorial I showed myself running both the stopwatch and the Zahn cup, but in the lab I would definitely recommend having split off your group into partners and have one person operate the Zahn cup and the other to start the stopwatch, just to try to eliminate any human error, as well as have the same person operate the Zahn cup for all the temperatures that we're looking at, just to, again, make it more accurate as far as reproducibility. All right, but enough about Lab 1. Let's go check in with Liv and get some tips about Lab 2.
Hey guys, welcome to Lab 2. This is absorption kinetics with Kool-Aid dye. First thing you need is yarn, and you're gonna need a lot of it. We made that mistake. We did not use enough, and it did not go well for us. Also, bring scissors or you're gonna be trying to bite it off. This is a cuvette, and it's gonna be your best friend for this lab. This is what you're gonna put your sample concentrations in so that you can measure them with this spectrometer. So I'll show you how it works. So you open this lid, and there's these 6 slots, and you're gonna make sure that you put the cuvette in one of the slots. And you're gonna wanna make sure you organize your trials. So you're gonna do 3 temperatures: room temp, cold, and hot. And so if you put the cold in the first slot, the cold always goes in the first slot. Close it up, turn it on, and you'll get graph data on the computer. All right, we're gonna talk more about this cuvette. If you see here on the cuvette, it has a little arrow. That's gonna be the side that you want to go sideways, so that this clear part is where the light is gonna go through. Also, especially with the cold one, there's gonna be a lot of condensation on the outside, and that's gonna mess up your spectrometer reading, so you're gonna wipe it off with a chem wipe. All right, general tips and tricks for this lab. Make sure you meet with the TA before you get to this lab so that someone can learn how to use the spectrometer, and that person's gonna be in charge of the spectrometer the whole time. Teamwork is key for this lab. You're gonna be wanting to run all your trials all at the same time so that you can get this done quickly, because each trial takes a while, and so teamwork is key. All right, let's go check out what Logan's doing in lab 3.
All right, come with me to lab 3. So lab 3 is going to be your CSTR concentration profile lab. This here is the lab equipment setup, so it's pretty complex, probably the most complex one in all the labs. So I'd recommend you meet with the TA beforehand. Learn how to use the knobs, learn how to use the system, learn all the safety precautions with it. So over here on the right, these will be your feed tanks. For your feed solution, make sure you use some sort of color food dye in there. We used red, a few drops of just the food dye. It goes a long way, allows you to see over time how the concentration changes via color. Over here, so these are going to be 3 CSTRs. Important to note, I don't know why it's like this, but for your data purposes, this will be CSTR 1, 2, and 3. But your conductivity readings are going to be flipped. So this is the conductivity reading for 3, 2, and then 1. Then for your exit tank, so watch this very closely during your experiment. Ours overfilled once. You got to be prepared to switch it out or to adjust accordingly. And then finally, for the cleaning throughout the trials, it's very important that you make sure these get back down to 0 conductivity. So use the siphon to pump these out and replace the DI water a few times and flush more water through it until the readings are back to end of 0. It's important to replace the water when you're cleaning it out. And finally, 2 more things. Use a lot of water in this lab. Be sure to have a lot of water on hand. Use these big jugs, fill them up. And then finally, it does take quite a lot of time to be prepared for that. Adjust your inlet pump speeds and your trial timings accordingly. All right, we come to lab 4, and don't forget your hard hats. All right, hard hats on. Let's head into lab 4. Gonna need all hands on deck. Safety is very important in this lab. It's the main unit obstacle laboratory classroom, so beware of falling objects.
Safety first! Welcome to the piping apparatus. This is the main part of your lab. At the top here, we have our 90-degree elbow bend fittings. Then we have 3 valves, and then this is our straight rung. These are pressure gauges that you're going to be able to use to determine pressure drop. And then these are the main focus. These are the valves. It is important to come in early to determine what type of valve it is and how many turns it takes to get it completely open so that you can calculate percent openness of the valves for your experiment.
So this is where the outlet flow will be. You want to keep this gauge open at all times, all the way open, so that you don't introduce any variable. And then over here is where you want to drain the water. So you want to keep it here at all times. You don't want to try and prop up the hose because the water pressure will cause it to go everywhere. So make sure someone always has their hands on it and that it's always going to the exit.
Another reason that teamwork is so important in this lab is because we will be needing volumetric flow rate calculations. In order to do so, we're going to be calculating volume at different time intervals. So while I'm running the stopwatch, Logan's manning the graduated cylinder, and after I stop it, we're going to be reading the volume and collecting that data in order to calculate flow rate later. All right, so to give you a better idea of this teamwork close up, I'm manning the stopwatch and writing on the data sheet. Olivia is looking at pressure calculations. We got Logan emptied out the water, and Alyssa giving me that volume measurement.
So like I said earlier, this lab can get quite messy, so let's not forget about cleanup.
Woo!
So that was lab 4, now we're gonna go head on to lab 5. No need for this hard hat anymore. So this is lab 5 where we look at the cooling profile of spheres. So over here is where the spheres you can choose from are. We 100% recommend completely ignoring these. Even these are a little iffy because the smaller spheres will cool faster and you'll be able to get a more thorough experiment. So these are the 2 we went with so that we could analyze different materials, but they're the same size so that we're keeping that variable independent. So over here is where you're going to heat the spheres. There's nothing in it right now, but you'll want the temperature set a little higher to the temperature you choose to analyze. Anytime you're handling it, you want to use these gloves to protect from the heat. And then you'll use the tongs as well so that you never reach into the box. The spheres will heat up really quickly, so you don't have to leave them in there too long. And then over here is where we'll analyze the convection. So you can analyze it while it's still, and that'll be free convection, or you can do forced convection using these different pump settings. And there's 3 choices, 1, 2, and 3. And to get the velocity, you'll use this anemometer. And you want to make sure you set it at the same distance away from the fan as you set the spheres. And then you'll start it. And we recommend waiting till it gets to full speed before you even start reading this to get that velocity. So those are our tips for lab 5. Now that we're out of the lab and back in the classroom, we want to give some general tips to make y'all's class experience go smoothly.
All right, firstly, be sure to meet with the TA or Dr. Esfahani before every lab so you can get a good understanding of it and get some additional advice. And then secondly, communication with the group is very important. Be open about your commitments and your timeline.
All right, so some additional tips for your proposal meeting. Time management is a really crucial part of these labs, so make sure when you're making your theoretical calculations that you're allowing yourself the ability to complete 3 trials in the 3-hour allotted time slot of the lab.
Timeliness is super important in this lab. Make sure you guys are working on proposals well ahead of time as well as reports, and that you were working together so that everyone knows what's going on.
And then the last tips I want to give you have to do with more of the technicalities during the proposals as well as the reports. So you want to make sure you number all the pages so that you can easily refer to pages and the proposal meetings go smoothly. And then you also want to make sure you do the correct labeling for the figures and tables with the figure 1 or whatever number and then a dot right after it in bold and then a description for each of them. For figures, they'll go underneath, and then for tables, they'll go above. And then that's all.
And that will be the conclusion of all of our recommendations for this lab.
We want to thank Dr. Esfahani and the TA for all their help this semester and making it a great experience for all of us.
Thank you guys for watching.
Teammate out!
Bye.